Good morning, ladies and gentlemen. I am Miss Lam Man Nhu, and it is my honor to present you the research, the cause-effect correlations between cavitation phenomenon and lesions in coronary artery. Before starting, please keep in mind that the presenter and the co-author have no relevant financial or commercial relationship to this course. And here's the overview of my presentation, showing as a graph chart. Our hypothesis is based on the observation of damage caused by air bubble rupture in domestic and industrial pipes. This is also called the cavitation phenomenon. Basically, the mechanism is when the static pressure is less than the phase pressure, then the bubbles are formed. In contrast, when the static pressure is higher than the phase pressure, then the bubbles will implode. The research team select the coronary angiogram with 1 to 2 lesions. Frame by frame, at 15 frames per second, the angiogram will examine for plaque location, time and length of coronary segment turbulence, reversal flow, and stagnant flow. The coronary artery should be properly contracted and should capture the whole artery in full length with all the frames totally inside the screen. Then stop the injection. At the moment, blood in white color flows in, and we saw the movement and interactions of the coronary flow. To review, right-click and choose the key image. To go through each frame, use the up and down buttons. Moving on, we need to review some kind of classifications in CAD. The first one is the classifications of coronary lesions, including 3 types. Type 1, shock-concealed lesions of moderate severity. Type 2, shock-mill lesions. Type 3, minimal diffuse lesions. Not to mention, the classifications of flow abnormality also have 3 types. Type A, laminar flow. This is well-organized flow in parallel layers with a pointed tip. Type B, turbulent flow, is represented as a disorderly mixture of plaque contract and white blood. Type C, retention peripheral flow. Non-zero stagnant contract at the peripheral layers. When it comes to the flow chart in matching lesions with flow, here's what the research team is going to do. In each patient, doctors will separate the coronary artery into 3 segments: the proximal segment, mid-segment and at the stop line, and the distal segment. In each segment, doctors will go through step 1. Find out which types of that flow. It could be A, B, or C. Step 2. Determine all kinds of lesions from 1 to 3. Step 3. Find the stop line. And step 4. Match lesions with flow. Working on the research of 50 patients, here's the demographic and clinical features. Almost all the patients are elders. The percentage of female is slightly more than male. About 30% of them smoke. Here's the research team also notes the patient's comorbidity, including dyslipidemia, hypertension, diabetes, previous heart failure, and anemia. In cardiovascular physiology, the flows were antegrade, rapid, and last 0.24 seconds to 0.3 seconds at the beginning of diastole. The antegrade flow then stopped for 0.6 seconds due to retrograde flow at the beginning of systole. This was identified at the stop line. So again, the stop line marked the location of the most turbulent flow resulting from a condition between the antegrade flow of systole and the retrograde flow of diastole. For instance, you can see on screen frame 36 of RCA. At the beginning of systole, the flow was stopped mainly in the central of the mixed segment, where the contract was found to be trapped, the arrow. You can see it more clearly the contract in frame 37. In order to analyze the result, here's the graph showing the percentage of lesions based on location at the stop line and not at the stop line. As can be seen, among 102 coronary lesions of 15 patients, 76% were found at the stop line, while only 24% at the non-stop line location. Comparing the lesions at the stop line of each patient with the lesions in the two other coronary arteries, the lesions at the stop line appear earlier and grew faster or become more severe in 76% of cases, which means about 38/50 patients. If there was a turbulent flow lasting more than 0.3 seconds, which is 5 images, then at the stop line, the change for a severe lesions were high at 34%. If there was a shorter turbulent flow, the lesions were less severe, about 65%. If any of these lesions were found next to a side brain of mild to moderate size, they would be the most severe stenotic lesions between all the coronary lesions of the same patient, 12/26 cases, or about 46%. Finally, may I remind you some of the main points we've considered. 1. The most common locations of the coronary lesions was at the stop line, where the anterograde flow collided with the retrograde flow. 2. Here at the stop line, the lesions grew faster, so the lesions became more severe compared with other lesions of the same patient. 3. The new technique of angiography reviewed the dynamic flows and their correlations, open new chapters in the clinical and interventional management of CAD. That brings me to an end of my presentation. Many thanks for your attention. I'll be glad to answer questions you may have.
Thank you for your presentation. I have a question for you. Do you know because I see that you show the relation between pressure and pressure and no. The velocity and the pressure. Do you know? Is there any the relation between the velocity and the pressure in the vessel? There is a question. Do you know the name of the this question? Questions. The relation between the pressure and the velocity. You know.
Yes.
Yes,
first, thanks. Can I answer now? So the velocity and the pressures based on the Mann-New's principle. Let me explain it further. That means when the blood goes through the narrow part of the coronary artery, the velocity is high, and also the pressure is low. There's a connections between them because it's based on the Bernoulli's principle. For example, when going through the narrow part of the coronary artery, the pressure is low while the velocity is high. So then we will have empty space after going through the narrow part of the coronary artery. So then as what I mentioned in the presentations, it will cause empty space, then it will cause bubbles, rupture easily. Then it will be the most dangerous diagnostic lesions.
Right. I think the velocity and there is a correlation between the velocity of the flow and the pressure in the vessel. And this there is a equation named Bernoulli. Shows the relation. The pressure is 4 times of the velocity square of the velocity. That means the velocity high gives the pressure high also. And that's why the velocity and the pressure play and roles in the lesion of the vessel. That's is there any question about?
So thank you for your answer. We would like to move to the next topic.